So we need to ventilate our lungs, and we as mammals have a very special muscle that is not seen in, say, for example, reptiles or amphibians. When we look at this structure, it is this muscle underneath our rib cage that is called the diaphragm, and this allows for what is called negative pressure breathing. So this is a diagram that demonstrates ventilation and negative pressure breathing. When we look at our lungs, we see that the lung has a volume, and there's also the movement of the air is due to changes in the volume of the lung and the differences in pressures. So let's look at, I'm just going to draw here. This is my diagram of my trachea, my bronchioles, right? And then my lungs. Let's see, right here. Okay. My diaphragm is sitting right underneath. Okay. So that's my diaphragm. Well, looks like a very unhappy face, doesn't it? So this is my diaphragm. Okay. Now, when the diaphragm is not contracted, this is when it is relaxed. It pushes on the lungs. And what that does is that decreases the pressure. Oh, excuse me, that increases the pressure, and that causes air to move out. So that would be exhalation. It is relaxed, okay? So when we exhale, our diaphragm relaxes. It might feel like something is contracting. And one thing that when we forcefully exhale, I think we get confused. We could actually contract the muscles between the ribs and forcefully, and also your abdomen, and forcefully depress and decrease the volume of the lungs so that air will move out. So this has less volume. So less volume and diaphragm relaxed. And so air moves out. Okay. If that diaphragm would contract, it actually moves down and actually kind of flattens out. So you notice when it's relaxed, it's dome shaped. That's kind of weird. But when we have inhalation, the diaphragm contracts. It is contracted. Okay. It moves down. There's less pressure, right? There's more volume, so put more volume in parentheses, more volume in your lungs. And so the air moves in. This less pressure, this is what is the negative pressure breathing. So this is a negative pressure. Okay. So I increase the volume, there's less pressure in my lungs, and so air will just move in. And this is a huge, huge advantage over being an amphibian and a reptile, because they actually have positive pressure breathing, which means that they have to force air into their lungs. So they essentially have to gulp air and force it against its pressure to go in to get to the alveoli for gas exchange to take place. So this negative pressure, this diaphragm allows for negative pressure. No diaphragm, so no diaphragm in the amphibians and the reptiles. This would be positive pressure breathing. And that takes energy And I would imagine it's kind of pretty annoying having to gulp your air and force it into your lungs. So that is the advantage that mammals have. Remember, birds are also endothermic, right? And they have a different mechanism of moving air into air sacs and through the lungs in one direction. And so their mechanism doesn't require a diaphragm, but ours requires a diaphragm for us to be more efficient at getting oxygen so we can produce more energy, so we can regulate our metabolism so that we are more efficient at producing heat and energy.